Okay. All right. I'd like to start out by thanking all of you for taking the time to attend our presentation this afternoon. Hello, my name is Lance Zurich, and today we are going to take a brief look at the two special curriculum-based sets from Studica that are designed for introducing students in middle schools, high schools, and homeschools to the fundamental principles behind mechatronics. Now, each of these sets are designed for conducting a project-based class, and this is where students will be required to design and build a series of original prototypes based upon their own research and their own activities. And each set includes standards-focused curriculum, which was created especially for Studica by noted educator and STEM expert, Tom White. And we'll talk about Tom in a little bit. But first off, we're going to start off where so many technology-focused presentations for education start off these days, and that's with the skills gap that exists. Now, when you hear someone reference the skills gap or the need for better STEM education in the schools, STEM, of course, being an acronym which stands for science, technology, engineering, and mathematics, what they're essentially talking about is the urgent need to prepare our students with the background they need to successfully compete in the job market which they will graduate into. Now, in the employment market that once greeted our grandparents or perhaps even our parents, a good work ethic, a strong back, and being able to take direction might have been enough to land a good paying job where many of the technical aspects could be learned on the fly. But now students must be prepared to enter a world that is increasingly focused on programming and automation and IoT and all sorts of rapid advances in all aspects of technology. Now, in short, students must be able to demonstrate technical literacy and aptitude if they hope to compete and succeed. This is, of course, why so much of the emphasis in education over the last decade has been on developing STEM skills. Now, every new advantage we enjoy, such as, for example, the tablets and the smartphones that all of us use daily, all these advantages were created because of individuals who helped to make those advances. Now, countries all around the globe, countries like China and India and so many others, are making major strides in developing new technological advances and preparing their own students to take their place in the future workforce. Now, here in the United States, we also need to prepare the next generation of graduates with the skills, the mindset, and the habits that will enable them not only to secure jobs, but also to be part of the next wave of advancements that we rely on to stay competitive on the world stage, and of course, to maintain our stature as a world power. Now, as I have no doubt that anyone attending a webinar like this is already in agreement about the importance of STEM and technology-focused programs, let's now move right along to the main topic, which is, of course, mechatronics. Now, mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, robotics, the Internet of Things, and computer science. All extremely important subject areas for students to be exposed to, and all skill sets that are highly prized in today's technology-focused job market. Well, just how prized? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. So while, of course, the students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, before any of that happens, they need to start developing the habits and the career focus as early on as possible in their schooling, in high school, if not even in middle school. Now, the dilemma for educators, whether in the classroom or in the homeschool environment, of course, is finding ways of introducing this type of subject matter to students in a way that gets them interested and involved in the learning process and not just memorizing obscure facts or ideas just so they can take a few tests, then promptly forget them. No. To best help students to be successful and to really encourage them to consider pursuing further education in subject matter like this, educators need to be able to present this material in a way that really makes it relevant to students, which of course means answering the eternal student question, well, why do we need to know this? And it also needs to be engaging in a way that holds students' attention much better than rote textbooks and lecture presentations might. And it has to be something that has real visible, real world applications in which the students can get involved in doing things and doing so hands-on. So it's with this dilemma in mind that we created the Studica Mechatronics program. Now these two special sets, one of which is designed as an introduction to the world of mechatronics, and one which is intended to be essentially a standalone class dedicated to the subject. These were each created to provide all of the materials in one place that educators will need to enable them to offer a project-based class that is relevant, engaging, realistic, hands-on, and which is crafted to meet the most current academic standards in place. Each of the two Studica Mechatronic program sets comes with its own detailed day-by-day curriculum document, which was created especially for Studica by noted educator and STEM expert Tom White. The curriculum comes as a downloadable PDF, which is available for free with the purchase of each set, in any quantity, I should add. Now, this curriculum is designed to align to the most widely accepted academic standards that are currently in place in the United States. The curriculum is also designed for offering a project-based learning experience. And this means that solving the problems that arise in each unit will require the students to be actively involved in the research phases, the design phase, the trial and error experimentation and activities, and in the building of actual working prototypes that will provide the required answers. And students aren't going to do this alone. Nope, they're going to be asked to work in small groups or teams, if you like, of 4 students each. This will help to develop the soft skills that students also need, maybe just as much as they need to develop technical skills. And of course, by soft skills, we mean things like communication skills, teamwork, adaptability, problem solving, and leadership. And finally, with the exception of some very affordable programming software, each set includes all of the physical building materials each group will need to enable to address all of the design projects presented throughout the course of the curriculum. The curriculum is designed to enable teachers of all types of backgrounds, and this means even teachers from non-science or non-technology focused disciplines. It's designed to enable them to have the information they need at hand to properly prepare them for conducting the activities and to increase the comfort in presenting this material to their students. So there won't be any training involved. All you have to do is, the curriculum is designed that it's in such a way that it's clear and easy to follow, and it provides a clear roadmap for student learning. Various supplemental materials are also included, both in link form throughout the curriculum and also at the end of each unit. And there are also special tutorials on familiarizing students with the building system that they will use to address the projects that are presented in each of these sets. The units in the curriculum are designed as a series of projects. Now, each of these projects is presented to students in the form of an engaging real-world style scenario where students must work together in small teams. Again, these are the groups of 4 students per group to create a solution to this problem. The project units each contain embedded academics. At the end of each of these units, students will be required to make a formal presentation of the prototype they have created to address this particular unit's real-world scenario and explain the reasoning behind the way they constructed their prototype and why they made the decisions they did. There's a technical literacy task driven by each of these projects. As students work to address each of these projects, they will acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are acquired through the carefully designed enabling activities. Now, again, as required by each project, students will be asked to create original prototypes, any required programming-based solutions, and they're also going to be required to maintain detailed documentation during every phase of the entire process. Now, as I already mentioned a few times in the presentation, the curriculum that accompanies each of the Mechatronics program sets was created especially for Studica by a man named Tom White, and you see a picture of Tom over here. Now, Tom is a noted educator who's been involved in teaching STEM and technology since the 1970s, designing programs for educational institutions as well as for industry. In fact, as an expert in hardware and software integration, Tom has been pivotal in introducing subject matter like CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. The standards addressed in the Studica Mechatronics programs are the most widely accepted standards that are currently in place in the United States. Now, these include the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K-12 and the standards for technological literacy. Now, as I mentioned earlier, the programs are designed to be project-based. When students ask, why do we need to know this? It's usually because the subject matter has been presented in a way that might come across as too abstract to be useful and applicable in their lives. Now, with this project-based approach, students see firsthand why these things are necessary and they see where they're useful. The concept of working with small groups to solve the project problems that presented in the scenarios also helps students to develop the high demand soft skills that I mentioned before that employers are looking for. Again, things like communication, analytical skills, quantitative skills, flexibility, adaptability, and problem solving. In this project-based format, all of the subject matter is integrated. And by that, I mean that the math is integrated with the reading, the writing, and so on, which is really ideal for a STEM education program. Also, because of the manner in which students must approach each of the projects being put forth in the curriculum, again, with the research, the testing, and the group give and take, just to provide a few examples, it allows for a much deeper exploration of problems than traditional teaching methods might allow. The projects presented in each unit are also designed so that if you have several groups working on the same project, you should see variations in their prototypes and, of course, in their solutions. Now, this could, of course, be because of creativity or differences in research and approaches taken by each group, but in any case, students get to see firsthand that problems can have many different answers, and that often there is not only one right answer, and perhaps there's an even better answer. Each project in the curriculum presents students with the opportunity to plan, organize, and conduct research. The enabling activities that students are asked to engage in provide them with the skills and the knowledge they need to draw on to complete each project just in time. And students will be required to do extensive research as they complete these projects. Research that is utilized in the design, the prototyping, the testing, the evaluation, and the redesign phases of each solution. And once again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough materials for teams of 4 students. Now, this team approach, as stated before, helps promote soft skills such as communication, the ability to work well with others, and leadership. And the sets offer an easily scalable approach for the teacher. Just divide the number of students in your classroom by 4 to determine the number of sets that you'll need for each class. Once again, everything you need to conduct the program, with the exception of the programming software that I mentioned before, is included inside of each box. Access to the free curriculum download is included with the purchase of each set, once again, in whatever quantity you purchase. Also included are all of the building materials which students will use in the creation of each of these prototypes. Now, the materials are from the unique Fisher-Technic building system, and they're among the components that are included in each of these 2 sets are 2 robotic controllers, such as you see on your screen now, and 2 power supplies. Of course, this might bring up the question, so what is Fisher-Technic? So for those of you who may not be familiar with it, let me provide you with just a little bit of background. Fisher-Technic is a flexible and innovative construction system. Now, unlike other popular construction sets that are usually designed to simply stack, Fisher-Technic was created with more of an engineering mindset. The core building block in the Fisher-Technic system is unique in that it allows attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place using a tongue and groove assembly method. The system also includes a wide selection of very specific parts, variations on gears, on girders, sensors, and so much more, which will allow technical builders to address equally specific design needs. The Fisher-Technic system was created back in the 1960s by German inventor Arthur Fisher, who's noted for countless innovations used in the construction and the automotive industries. Mr. Fisher, at the time of his death in 2016, had amassed more patents in his own name than Thomas Alva Edison had amassed during his own lifetime. Besides Fisher Technic, Mr. Fisher was the inventor of synchronized flash photography back in 1949, as well as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fisher Group, employs thousands of individuals worldwide, producing many variations of fastening devices used in building construction, as well as components used in automobile manufacturing, and they also are known for providing consulting services related to automated processes. Now, with all of that said, let's begin looking at each of the two individual sets. Now, we're going to start off with the Studica Introduction to Mechatronics Program set, or for those of you who like acronyms like STEM, you can refer to this as SIMP. Now, this set is designed to help provide a well-rounded introduction to the core concepts of mechatronics. Each set includes access to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, of course, written by Tom White. The curriculum contains enough activity material to fill approximately 45 academic hours. Now, as such, we recommend this set for insertion into regular class activities, to be used as a short class unto itself, for after-school use, or of course, for homeschool use. The curriculum created for the set is standards focused, again, using academic standards most widely recognized in US-based education today, and it's designed for offering a project-based program. The set is designed for use in middle or high school classes, or again, for addressing these same grade levels in a homeschool environment. The set contains a collection of over 700 Fisher Technic building components, and this will mean everything from gears and wheels and axles, blocks, sensors, and a whole lot more, as well as, again, 2 robotic controllers and 2 power supplies. Only the required robotic control software, which we will discuss later, is not included, but everything else is included, and it is, again, the software itself is very affordable and available separately. The curriculum for the Studica Introduction to Mechatronics Program set consists of 6 project units, and they are as follows: sketching and documentation, simple machines, mechanical systems, basic electricity, the conversion and storage of energy, and an introduction to control systems. And there are also activities included to address the following topic areas that come up during the course of the curriculum: sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flowcharts, using software and robotic controllers, working with sensors such as the digital switch and the digital phototransistor, working with open loop and closed loop programming, digital branching, analog sensors such as the photocell LDR, working with analog branching, working with other analog sensors such as the NTC resistor and the potentiometer. Now, before we go further into the structure of the curriculum, we're going to first look at what's covered in the second set. The second set is the Studica Teaching Applications of Mechatronics Program, which, going back to the acronyms, can also be known as STAMP. This set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. The set comes with access to a free downloadable 400-plus page curriculum document entitled Mechatronic Applications, again by Tom White. The activity materials in this curriculum document, when used in conjunction with the contents of this set, are designed to fill approximately 180 academic hours. So we mean essentially 4 times the amount of academic hours is covered by the previous set. Now, as such, this set can be used as a more expansive version of the material touched upon in the first set. It can be, and it's designed for those educators who are able to dedicate a daily class period of approximately 50 minutes a day, 5 days a week, or the equivalent, each week for a full academic year. Again, the set is designed for offering students a standards-focused project-based learning experience. And again, it's designed for use in middle school, high school, or for addressing similar grade levels in a homeschool setting. The materials in the set consist of a selection of over 1,200 Fisher Technic building components, so 500 more than in the last set. And once again, this is going to include a wide array of gears, blocks, sensors, axles, and much more, as well as, again, 2 robotic controllers and 2 power supplies. And of course, again, software is required for the set and is sold separately, and we'll talk about that. Now, there are twice as many project units included in the Studica teaching application of Mechatronics program set as there were with the previously discussed set. And this will include units on the following: sketching and documentation, simple machines, mechanical systems, basic electricity, and this is followed by project units focusing on the creation of a garage door, an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, links are provided to tutorial sections and activity materials for students to utilize, and these include sections on the following: sketching, linkage diagrams, schematics, Ohm's law and power, flow charts, using the programming software and the robotic controllers, working with open loop programming, working with sensors such as the digital switch and the digital photo transistor, closed loop programming, digital branching, logic gates, combinational logic, edge triggered versus level triggered, pneumatics, variables, positions, recording positions, creating a graphical user interface, working with analog sensors such as the photocell LDR, the NTC resistor, the potentiometer, and working with data. Now that we've had a look at how each set differs and the specific subject matter covered by each of the sets, let's now look at exactly how the curriculum itself is structured. Now, both versions of the curriculum share the same format when it comes to the structure of each of the project units. And as already discussed, each version will include tutorial materials, activity materials, standards, and other supplementary materials. Now, in each case, the curriculum is also designed to be turnkey. Now, what I mean by that is you won't need any special training. You don't have to attend a class to know how to teach this. Essentially, each unit is designed to clearly spell out everything being addressed, and again, to provide tutorials and other information as the topics arise. Now, this was done specifically to enable teachers from all kinds of backgrounds, and this includes those teachers who come from a non-science or non-tech focused background. It's again designed to enable you to quickly become comfortable with delivering the material simply by reviewing each section before you present it in class. Each unit presented in the curriculum for each of these 2 sets includes the following sections: the introduction, the purpose of the project, the concepts to be addressed, an outline, the academic standards, assessment rubrics, the essential question, the student scenario, the daily plan, vocabulary words, and other resources. Now we're going to look at each of those sections a little bit closer. Each unit starts with an introductory section and the purpose of the project. Now, just as you would likely gather from that name, this is the section that provides a brief description at the top of the topic that will be explored in the coming days and the coming activities. And this is also the section that seeks to clearly spell out to the students why they are learning this material and why it's important for them to learn and know. The next section focuses on the main concepts to be addressed in the unit. And these can be thought of as the broad ideas that will be explored in the unit and the core information that students should take from this project that will be essential for them to understand and utilize, not only today, but to draw upon as they move forward in STEM fields of study and, if they choose to pursue it further, in STEM-related careers. Following this, we encounter the outline. Now, in this section, we drill down more specifically to what is going to be addressed in the unit. And now, as the example shown on the screen right now is taken from the unit that addresses aspects of programming, you will see that we touch upon areas here such as the methods for writing programs. So we get into things like flow charts and word problems, program characteristics, open loop or closed loop, branching, for example, digital, analog, subprograms, and so on. The next section of each project unit focuses on the specific academic standards which will be addressed in that unit. As you will see, this includes the college and career readiness math standards, reading standards for literacy and history and social studies, writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for grades K to 12, and the standards for technological literacy. Each project unit also contains rubrics, and this is going to include rubrics for the specific project being covered, as well as general rubrics for literacy tests. After this, we find the essential question, and this can be thought of as the big picture question that will be focused on in each of the smaller individual activities, and of course in all the aspects of the larger project which students will be asked to complete in this section. The student scenario is where the specifics of the project to be addressed are finally spelled out. Now, again, this is presented in the context of a real-world style scenario where students are presented with a problem that needs to be solved with the creation of some sort of device, some sort of machine, or some sort of mechanism. Now, as I mentioned before, students don't do this alone. They have to work together in small teams to craft their answer to this challenge. Solving this problem will require each team of students to design a unique and original answer, which once again will usually be in the form of a working prototype, along with whatever programming may be required to keep that prototype going. Now, just to provide an example, if you look closely at the student scenario that I'm sharing on the screen now, you will see that the project in this unit has each group of students taking on the role of a design team employed by a firm that manufactures garage door openers. In this particular case, students are being required to design a specific type of control system for a new line of garage doors. The manufacturer's requirements are spelled out, and this is going to include things such as, in this case, the use of limit switches, meeting certain safety codes that require methods for sensing if anything is in the way of a closing door, and it's also going to have to include the incorporation of an automatic light. Now, again, each team of students will be tasked with creating both a unique and original prototype, and in this case, that's of course the garage door opening system, as well as the programming needed to control that prototype. Now, as they move through the challenge being put forth in this scenario, each student team will be required again to document the entire process in both a design notebook and a digital engineering journal. Again, noting all the research, all the trial and error experiments, keeping copies of all design sketches and revisions, and so on and so forth. Now, at the end of each of these project units, each team of students will be required to make a formal presentation in front of the class, during which they will be asked to demonstrate their prototype and programming in action, much as they would be required to do for an actual employer or client in the real world. The next section we encounter is the daily plan. And this is the section that spells out clearly, both for the students and for the teachers, what's going to be expected of students, how the teacher will conduct the day's classroom activities, and what specific subject matter is going to be covered. Now, some days may involve discussions. Other days might involve research or perhaps building small projects that will help provide the building blocks that students will draw on to complete the larger projects as described in the student scenario. But in short, you can think of the daily plan as being, again, that roadmap designed to keep everyone on the same path. You will see, too, that along the way, as different aspects are addressed in each day's activities, such as, again, what is required in a design notebook, or how to use the control software, working with the controller, or working with flowcharts, or what have you, that as each of these things comes up, there are links to sections that will provide further instructions and information on each of these areas. So again, the students don't know how to use the controller, they can click on the link, they'll learn their way around. At the completion of each unit, after the last day of the daily plan, there's a section containing vocabulary, which is of course important words and terminology that are introduced during the project unit, as well as a selection of useful resource materials. Now, these resources can contain a mix of different types of material. They can have everything from carefully vetted websites and video links to PDF documents, in some cases PowerPoints, so on and so forth. Now, besides the project units, each of the curriculum documents also includes a special tutorial section designed to educate both students and teachers on how to use the Fisher Technic building system. Now, this includes information on how the parts fit together, using again that pin and groove assembly method I talked about, identifying the different types of parts, from the various types of girders and blocks, the different types of axles, the different types of gears, rivets, and much more. And students are also going to get to build a very basic sample model just to help familiarize them with the building system before they move on into the larger projects in each of these units. And as learning about and maintaining proper documentation is one of the areas that we stress in the course of the curriculum. There is a section which details just exactly what is defining each type of documentation listed on the screen now, and what the students are going to be required to have for each of these. And finally, as the process of conducting these types of more open project-based class activities might be new to many teachers, there's also a section that clearly discusses project-based STEM education and its benefits. And that completes our overview of these two sets. So let me just quickly review the contents and the purpose of each set, but this time I'm going to include the pricing. First, we have the Studica Introduction to Mechatronics Program set, which again is designed as a standards-focused, project-based introduction to the core concepts of mechatronics. Once again, it includes the highly detailed 242-page curriculum document entitled Mechatronics Fundamentals, written by noted educator and STEM expert Tom White. Now, this curriculum, when used in conjunction with the building materials in this set, will provide teachers with enough activity material to fill approximately 45 academic hours. It is again designed for those educators who wish to offer a shorter form class on this material, who wish to use it as part of an after-school program, or of course to use it for homeschool use. The teaching material is designed for use in middle schools and high schools, or again by homeschooling parents seeking to address STEM and mechatronics for these grade levels. The physical materials included in this set include a section of over 700 components, including blocks, gears, sensors, and much more taken from the Fisher Technic building system, as well as 2 robotic control units and 2 power supplies. These materials will again be used to construct the mechanical prototypes addressed in each project unit of the curriculum. The software is again required, and we're going to touch upon that in just a moment. Again, each of these sets is designed to be used by teams of 4 students at a time, with pricing starting at just $699 for a single set, and discount classroom pricing for groups of 20 students and up is available by quote upon request, so please contact us about that. Next up is the Studica Teaching Application of Mechatronics Program set, again designed as an in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics, which is all based around a highly detailed 401-page curriculum document entitled Mechatronic Applications, again written by noted expert Tom White. Now, when used in conjunction with the building components included in this set, the curriculum is designed to provide enough activity material to fill approximately 180 academic hours. This is designed specifically for those teachers and homeschoolers who are able to dedicate a daily class period of 50 minutes per day, 5 days a week, or the equivalent, to this subject matter for a full academic year. Again, the set is designed for use in middle schools and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics for these grade levels. Each box contains an assortment of over 1,200 components, once again, 500 more than the other set, from the Fisher Technic building system. And this again includes blocks, girders, gears, sensors, axles, and a whole lot more, as well as 2 robotic control units and 2 power supplies. The required software is sold separately. It's coming right up. We'll talk about it. Once again, each set is designed for use by teams of 4 students, with pricing for a single set starting at just $799 each, a real bargain. And again, discount classroom pricing for 20 students or more is available upon request. So just give us a call, send us an email, and we can get you a quote on that. And as I mentioned that software is required, let me address that real quick as well. The software that's used with this is Fisher Technic RoboPro software, which is graphic programming software. And this means it uses a flowchart style design where using various icons which students arrange in a link together to create the programs used for each of these models. Now, the nice thing about graphic programming software is it's ideal for teaching the fundamentals of programming to users of all levels. Pricing for a single user license of RoboPro is only $36 each. and unlimited single site school licenses, meaning that you can have unlimited users at a single site or building with this license. So that means if you have a single building, and whether you have one computer, 100 computers, 200 computers, or what have you, the cost is only $120 per site license. Now, please note that these are not subscription prices. These are not annual licenses. These are non-expiring licenses that you can access and use as long as you have the software disk, like the one you see pictured, which comes with each set. And as long as you were able to install this software on a compatible Windows-based desktop or laptop computer using Windows version 7, 8, or 10. Now, updates to the software can be downloaded as they come up free of charge to registered users from the manufacturer's website as they become available. So at this point, if anyone does have any questions, this would be the time to, again, use either the chat window or the question and answer window, which can be found on the Zoom toolbar. If you open those up, feel free to type any questions you might have in there. I'll be happy to answer them. I will take a drink of water while I'm waiting for any questions to come up. Going once, going twice. What I will do is I'm going to forward. You can still, if you are typing a question, what happens after 1 year? Do you need to buy whole kits again or replenish? This is a good question, and it's a good thing you asked, because I neglected to mention it. With the Fisher Technic building system, as the students are working through all of the projects, because it's a building system that, like I said, uses a tongue and groove assembly method, nothing is being soldered together, nothing is being screwed together, well, in some small cases, some things will be screwed together, but that will be useful through all the projects. Basically, students are going to build each of these projects, and at the end of that unit, take them apart, and then you start building the next one. So you can just keep reusing all of the parts that are in these sets to build all the various models that you may wish to build, take it apart, and then you move on to the next one, and you can reuse them for next year. The one thing I would say that I will point out is if you had multiple classes that you wanted to have using these sets, you would need to dedicate sets to each class period that was using them. So for example, if you were working with a school who had 3 classes dealing with this, each class would need their own group of sets during the period they're going to be using it, because of course some of the projects are going to take a longer form than 1 class period or what have you. But everything is fully reusable. If you did need any additional parts, Studica is actually the distributor for the Fisher Technic building system in the United States and Canada. And we sell all the spare parts in whatever quantity you might need them. So if you needed 1 part, if you needed 20, whatever the case may be, we list spare parts on our website and you can purchase them that way. Tell me a bit about ongoing tech and/or instruction support. As I said, it's the way this is designed. This is not something where you're going to be getting training. You're not going to be getting that kind of support. It really is designed, the curriculum is designed so you as a teacher should be able to review the material and everything should be spelled out for you. If anyone did need to see a sample section from the curriculum, we can make that available to you. That's not a problem. You can contact us using the email that you'll be getting tomorrow. I believe Christy will send it out. But basically, it's designed in such a way where you should be able to review that material. Same thing when I mentioned that there are tutorial sections on using the system itself. I know people like to go and take classes. Well, maybe not so much right now, but normally, yes, we like to go and have hands-on training with things, or to see YouTube videos on things, which you can find in some cases with Fisher Technic products. But for this, really, if you follow the instructions that are included in the set, like I said, we'll walk you through some simple basic models. There, I believe, are also some instruction sections that are included in here from various Fisher Technic sets, where once again the building system comes from, which will show you how to build some basic models so you can learn your way around it. But again, this is really designed to be kind of turnkey, so you can just kind of work through it yourself. How does the curriculum compare to a typical robotics class? Well, again, this is mechatronics, so it's gonna cover different things. Honestly, I think in some cases it may be more in depth. It depends what you're trying to do. I by and large, the teachers that I've talked to, and I've been working with the Fisher Technic system since 2010, the teachers I've talked to who have used Fisher Technic and have used the Lego system, and this is not a knock on the Lego system, but tend to like the fact that the Fisher Technic system offers them a lot more possibility as far as where they can grow with it, where they may have seen certain stumbling blocks with the Lego systems. And again, it's not a knock. I mean, you can have preferences, but it's going to be in some ways a little more sophisticated, I would think. Also, Fisher Technic is classically used for, it's always been used for teaching technology, for teaching engineering, and things of this nature, for teaching automation. A major focus of, just to give you an idea of even how they differ, a major focus of what Fisher Technic does is building simulation models, industrial simulation models used for training incumbent workers or what have you, on things like using commercial PLCs and programmable logic controllers, and working with the programming on that and what have you. So Fisher Technic actually builds factory simulations that which simulate the various machines and devices that are used in a factory setting, in working with high-end automation, showing people how IoT works, working with where you're basically can control the system from a cloud-based dashboard and what have you. And these are things that honestly I haven't seen Lego touch yet. So, once again, there's a different level of sophistication with it. Some people like Lego because they have a familiarity with it, and I mean, we've all played with it as kids or stepped on it as adults. But yeah, it's just a different thing. Are there locations using this system in New Jersey? I personally don't know, because I kind of oversee everything. I would probably have to ask my New Jersey rep. So if you wanted to contact us, we could possibly put you in touch with somebody who's using that. I will tell you that the Studica variation of the Mechatronic system itself, there's not a lot of people using the Studica branded Mechatronics program yet, but there are a lot of people who've been using Fisher Technic components, and we have other Fisher Technic specific curriculum-based programs that we also offer. And there are a number of schools all over the country, actually all over the world, that use our Fisher Technic curriculum-based sets. So yeah, I mean, there's plenty of those. Like I said, the Studica variation is something we put together this year. So it's had less time in the marketplace, but the Fisher Technic system itself has had many years in many schools. Anyone else? And also, I should mention, and I'm going to just jump ahead to the slide here because it has our contact information on here, which is kind of important. If you do have any questions, anything that comes up now, I will keep answering as long as things pop up. But if you did have any questions, as you'll see up on the slide I have here, taking the next step, of course, if you want to request a quote, if you want to speak to your dedicated educational representative, as I mentioned, I, for example, wouldn't deal with the schools personally in New Jersey. That would be our dedicated educational representative for New Jersey, who I believe is Janet Ebert, what have you. But whether you need a quote, whether you want to get more information on any of these products, whether it's the products that I've been discussing today, these curriculum programs, if you'd like to see a sample of the curriculum, what have you, if you'd like to know more about the Fisher Technic system, we have a lot of information on our website on both of those aspects. But if you want to ask us anything, our number in the US is 888, of course, toll free, 888-561-7521. We are in the office and answering phones from 9 a.m. to 5 p.m. Monday through Friday, with the exception of holidays. So we are here and we're ready to help you. If you have general questions, need a quote, what have you, you can email us at info@studica, studica.com. If you have a question specifically for me, any of these things that came up over here, any other questions you might have, something you think of after, you can email me directly. I will be happy to answer anything, whether it pertains to something I touched on today, some other aspect of Fisher Technic. It's It's all fair game. My email is lance.zurek, lance.zurek@studica.com. So any of those, whichever works for you, please move forward. Of course, if you do need quotes, I won't be the person to prepare those. Again, those can just go to info@studica.com. But any questions on anything Fisher Technical related or anything I talked about today, anything you'd think I didn't talk about today, please ask. On that note, since I don't see anything else being typed in, I just want to thank everyone for taking the time to attend. I know these are strange times we're going through, and it's a holiday that we're approaching. So I appreciate you making the time to attend. I hope you all stay safe, stay well, and we look forward to speaking with you soon. Have a great afternoon.